Good morning. Welcome to the July NTSA Tech Grove Connect webinar. We're so thankful for all of you that have chosen to take your time today to learn about learning engineering. I'm Carol Ann Logue. I am your host for the webinar, and I am director and co-founder of the Central Florida Tech Grove. And it is our honor to partner with NTSA on this webinar series in which we shine a spotlight on the teams, the technology, and the opportunities behind the best papers and tutorials from the most recent ITSIC. So our guests today will be sharing insights with you about their tutorial that they did on learning engineering at ITSIC 2022. And I know I'm looking forward to learning all about it. And all of you, many of you submitted a lot of questions that we'll try to get to as well. Before we dive into all that, though, I do want to tell you just a little bit about the Central Florida Tech Grove. Some of you have heard of Tech Grove. Some of you perhaps have not. We are a Department of Defense funded innovation community located physically in Orlando, Florida, in the midst of Team Orlando, which is a very unique multi-DoD service, multinational security agency collaboration around human performance for our military and national security personnel. Tech Grove was stood up about 2.5 years ago. We are focused, as you can see on that slide, on human performance in modeling, simulation, and training. What really makes us unique among all the DoD-funded innovation centers, though, is that we are multi-service funded. You see lots of logos along the bottom. Every one of those DoD service components is a member of and a stakeholder in Tech Grove, and we work with all of them collaboratively and individually. And Tech Grove is a partnership between the Naval Air Warfare Center Training Systems Division and the University of Central Florida Research Foundation. This is where we focus. I'm not going to go into all those acronyms. I think most of you that are joining us today, you're in this space, so you know what those acronyms are. You see along the bottom a lot of the priority enabling disciplines and areas of capability and technology that underpin this human performance modeling, simulation, and training industry. And anyone in those audiences and those areas are who we are reaching out to fulfill one of our 3 missions, which is to grow the defense industry base, help support transition and transfer of technology, and solve problems, address needs and gaps for our Tech Grove customers, members, which were those services that you saw listed on the first slide. We have a whole cadence of different opportunities, activities, initiatives, events going on that you can engage in, either in person in Orlando or virtually for almost all of them as well, because no matter where you are, we want you to be engaged with us. And I really appreciated that somebody asked the question, how do we stay connected to Tech Grove? So that question I am going to answer right now because it's really quite easy. Go to our website. If you're not already getting our emails and communications, fill out the contact us form on there, and that will get you right into our database so that you regularly get our communications about opportunities and events. 2 opportunities I want to highlight that are coming up here in the next month. We are coming down to the conclusion of our first ever prize challenge around live virtual constructive interoperability need that all of our customers are very interested in. And on August 1st, the 8 finalists will be in person in Tech Grove demonstrating and talking about their prototype solutions, and we'll see who those winners are that get that $100,000 in prize money. And then on August 15th, we are delighted to continue our partnership with Naval Surface Warfare Center Crane, Indiana, who will also be in person on the ground in Orlando, showcasing just a few of their fairly massive portfolio of IP, patents, innovations, and talking about all the ways that you can partner with Crane Indiana in the areas that they work in. With that, we're going to move to the reason that we're all here, which is to learn about learning engineering. And we're delighted to have Say Schatz with us, who is the founder of the Knowledge Forge. Love that name, say. And Jim Goodell, who is with Quality Information Partners. They are the authors and presenters behind the tutorial. Their bios were on the website where you registered, and they're going to go through their presentation, dialogue. Be sure you put your questions in the Q&A because we will be monitoring that Q&A live during the session, as well as getting to as many of the questions we can that were submitted ahead of time. So with that, Jim, welcome to the Tech Connect webinar, and it's all yours.
Thank you, Carol Ann. Let's kick it off with the definition of learning engineering. Learning engineering is a process and a practice that applies the learning sciences using human-centered engineering design methodologies and data-informed decision-making to support learners in their development. But you don't have to take my word for it. This definition comes from IEEE Icicle. Oh, I see Say is trying to, you're still on mute, Say. I can read Say's mind, and I think she wants me to define what.
Yes, please define Icicle for me. Sorry, I can't. It's not letting me do both the slides and the mute. So.
Okay. So Icicle.
Mute it there for a bit, but yeah. What is Icicle?
Is the industry consortium on learning engineering, and it's part of the IEEE. IEEE is the largest technical professional organization in the world. And it's the organization behind things that you know, like Bluetooth and the standard for Wi-Fi. And this is a great question. Isn't this just dressed up learning sciences? Well, it isn't. There is a difference between science and engineering, and a great way to illustrate that is with a story that started between the world wars. Because in 1928, Dr. Alexander Fleming discovered penicillin, and that was a scientific breakthrough. But there was a problem because Fleming and his colleagues at Oxford University, who were scientists, couldn't produce the drug at scale in the lab. And this was a timely problem because at this point, World War II was underway. A decade after the discovery. And soldiers and personnel were dying of pneumonia and infections during the war. So the scientists reached out to the US government, who reached out to US pharmaceutical companies who had chemical engineers to employ on solving this problem. And here's the bottom line. When the US entered the war, there wasn't enough of the drug to even treat a single patient. But by the end of the war, and even by the invasion of Normandy, there was enough of the drug. In fact, there was hundreds of billions of units of the drug being produced by the end of the war. So this is a victory for both science and engineering. The goal of science is to discover truths about the world as it is, and the goal of engineering is to create scaled solutions to problems using science as one tool in that endeavor. And the discovery and then engineering of the production of penicillin was credited with helping to win the war. Dr. Schatz?
Yeah, so this is a really good example of we understand learning science at a narrow scale, and we have almost, I would say, artists, right? People who are individual experts who are able to really effectively teach and train and assess and implement learning at a local level. I mean, think of some of your best teachers or some of your best mentors. These are people who have probably shaped your lives. You could probably think back to, Mrs. Jones in 6th grade who, said something in particular to you or drove your life in a particular way. That's amazing. That's like Alexander Fleming in the laboratory. Now, how do we start to reliably scale that up so we can produce the penicillin or produce the treatment of learning reliably at scale with efficiency? So not only do we need good quality learning science, but we also need to leverage those educators and other training professionals, those coaches, those mentors. Of course, we need subject matter experts. We need to include people who are expert at assessment, measurement, evaluation. We also need people who can design learning experiences. That's that integration of user experience design with learning so that we can actually use the systems that involve learning. We need people who design the environments, whether that's a schoolhouse or a training range. Of course, we need data scientists because Jim said data like 15 times already, because learning engineering is very data centric. And we need software developers, people who can integrate the digital technologies that are not always used for learning engineering, but are often used in the modern day. All right. So at this point, you guys are probably starting to like fall asleep because, you know, we need to engage you. So I'd love to hear from folks. Just write into the chat, which of these roles do you think you play on your team? Now, maybe you play all of them. Maybe you play one or two. But go ahead and start to chime in. What roles amongst this learning engineering team do you play? Because this is what learning engineering looks like. But it's not just this assembly line of people. Critically, it's about having shared understanding across this team. So a lot of times when we do instructional design, we take the concept and we hand it to a curriculum developer, and they, you know, make the ELOs and the TLOs, and then they pass it over to a software person who implements it in the courseware technology, and then they maybe pass it to a psychometrician who creates the assessments. What we really want is everybody sitting in the same room, having that shared understanding, working towards a common goal. And that's where learning engineering comes in. So it's not just an assembly line, it's an agile, collaborative approach. Oh, and by the way, the learner and the other stakeholders have a seat at the table too. This isn't just something that's done to other people. It's done by, with, and through the learners as critical stakeholders. So what we want to do when we talk about learning engineering, oh, and by the way, thank you guys for chiming in. Keep it up, keep it up. So when we talk about learning engineering, we start with the learner. We say, okay, who is this person? What do we know about them? You know, what kind of knowledge and skills do they have, their prior experiences? What are their personal identity or traits that are really not very changeable? Their culture, their interests, maybe their MOS in a military context. What kind of abilities do they have? So these could be cognitive abilities, different capabilities as far as like sensory abilities, like eyesight, fine motor control, those sorts of things. And what kind of states are they in? So you could imagine, for example, if you're working with a lot of warfighters, they might be in a state of fatigue, or they might be distracted because their boss is emailing them while they're trying to do your learning activity. So you want to take all of these personal characteristics into consideration. And then you want to think about how those interact with the learning activities. You know, what's the subject? You know, somebody have prior experience with that either supports or interrupts it. How about, is it an individual or group? What kind of instructional tactics or instructional strategies are you using? Are those appropriate for the learner? What's the modality? This is particularly relevant in a DoD context because not everybody can access certain kinds of modes on certain kinds of equipment. How complex is it? What kind of cognitive requirements are there, or time pressures, right? All of these things you want to think about how they interact with the learner and that person's context. And of course, all of this is within a larger context as well. The physical environment, you know, if it's accessible, if it's noisy and distracting, the social environment, whether people feel safe and supported, if they have the peer learners that they can also learn from. And of course, the technological environment. How is that learner interface, that user interface for the software? Is it supporting or is it distracting? Do people have Wi-Fi? Do they have the right kind of bandwidth? All of these things affect how effectively we learn. So you could have the best designed learning experience, right? You have such great graphics and assessments and everything. But if the user interface to access your amazing learning offerings is terrible, then nobody will make it to those learning offerings in the right kind of mindset. So you really see how all of these different factors come into play. And this is an important place to start when we talk about learning engineering. All right, so you might be thinking, all right, how can we do all of this, right? But this is where there are a lot of resources out there already for user experience design, human factors, human-centered design. Now, if we were doing a full-scale tutorial, we would probably go into this in detail. But what I will say is there's a great free resource out there from IDEO, the famous industrial designers. And you can go to designkit.org to check that out and get some free resources on how you can start doing human-centered design. But I digress. So let me hand it back to Jim, who can talk about how we integrate this human-centered design piece into learning engineering.
Learning engineering is a process, and a process is a series of actions or steps taken to achieve a particular end. All processes have inputs, process steps, and outputs. Now, learning engineering is an iterative process, and it's iterative in that there are feedback loops. So we are collecting data using sensors, and then using that data to inform adjustments to the inputs and to the system. And if from an engineering perspective, this is called a closed loop control system, and that gets you to the engineering. So let's take a look at the learning engineering process. It starts at the center with understanding the challenge. And we want to understand the challenge as a learning engineering team in context. So we want to understand the learners and the characteristics of the learners that we're trying to help. We want to understand the team that we have to work with and make sure that the team is suited to solve the challenge. If we need additional data to understand the challenge, then we go into an investigation stage and collect more data. The creation phase is also itself an iterative process because it's a design development process. And it's not just about designing learning experiences. It's about designing data instrumentation and designing implementation planning and everything that will be needed to address the next stage, which is implementation, which is moving the solution or an iteration of the solution out into the real world with real learners.
So, Jim, there are arrows all over this process model. It basically looks like spaghetti. What is going on here?
So, yeah, so the idea is you start in the center, but depending on the nature of the challenge, that determines where you go next. So you may go right to the creation stage, or you may already have a solution that, and the challenge is to better understand how it's used with a different audience. So then you would go to the implementation stage and collect more data about the use with that new audience.
So a lot of times when I explain learning engineering to people, I will say to them, take systems engineering and integrate learning sciences. And so some of you out there, in fact, probably a lot of you out there are familiar with systems engineering processes. And so you might hear things like agile, iterative, concurrent. Those are all the principles that you're seeing here. So if you imagine all of those best practices and then integrate learning, that's what we're talking about.
Yes,
and that's why there's arrows all over the place.
Yes, arrows. And we also think from an engineering mindset that this is a system of systems. Learning is a system of systems and all of the conditions that surround learning. So we're not just looking at the learning experience itself. We want to look for those challenges that in the environment and in other conditions that can affect the learning.
And that's why it starts with challenge in the middle, followed by context around it, because we really want to focus on that challenge. Like I mentioned a few minutes ago, if your big barrier to being successful is the terrible user interface, then that's the thing we need to address. If the barrier to being successful is the poor quality internet at a particular base, then that's what we need to address. It's not always about improving the curriculum or improving the multimedia.
And say there are other processes that are used for things like instructional design.
Exactly. And so this is one of the questions we got with a lot of you as you signed up. I already use ADDIE, or I already use the instructional systems design approach, or the systems approach to training, or, fill in your favorite acronym. How is that different from what you're talking about with learning engineering? So let me give you a few examples of how they're different. So the ADDIE model, or the traditional approach that we often see used to instructional design, tends to be a very content-focused approach. So I was mentioning about the Wi-Fi, I was mentioning about the bad user interface. Those are usually outside of the purview of somebody who's doing traditional instructional design, where a learning engineer would say, no, look, hey, my goal is to solve this outcome, and maybe the thing I need to address is the Wi-Fi. ADDIE, or instructional design approaches, tend to be very linear. So I'm going to do the first process step, and then I'm going to hand it to the next person, and they're going to do the next process step, and so on. So that old school waterfall model versus the more agile approach that we're talking about, that's iterative and concurrent and continuously improving. ADDIE tends to have an approach where we create the instructional product, the curriculum, the courseware, whatever, and then we're done. We declare success and we complete it. But with learning engineering, you continuously improve. Every time you offer that learning experience, you collect data, you continuously improve it. Even within the learning experience itself, if you can, you're collecting data and continuously improving. ADDIE and traditional instructional design tends to be more limited in scope, where learning engineering is broader in context, just like what I was mentioning. So it's not just a matter of, let me work on my curriculum, or let me work on my enabling and terminal objectives, but rather, let me think about the big, broader context of successful performance. And ADDIE tends to usually include explicit assessments. Like I'm going to have a multiple choice test versus learning engineering, which looks at a whole range of instrumentation, stealth assessments, other ways to do implicit assessments, to use that for sensors. And finally, ADDIE tends to have much less emphasis on data, where, as you've already gathered, we are talking about data a lot. Now, I recognize that I am kind of throwing ADDIE or instructional design under the bus a little bit, and I don't mean to. There are excellent designers out there who use iterative processes and continuous improvement and lots of data-driven approaches. The thing is, they do that despite these more traditional, more linear approaches that we tend to see in instructional design, versus having a framework that explicitly drives towards the learning engineering outcomes. And so that's the big difference. Now, you might be thinking, yeah, exactly. You've said data umpteen times. Jim, tell us how we could use data.
Sure. Learning engineering is data informed, and there are two parts to data informed decision making in learning engineering. The first is to get data, and our fancy name for getting data is instrumentation. And instrumentation can look like this. It starts with hardware sensors, and things that we're all familiar with: keyboard clicks and mouse clicks and taps on a tablet. It can include more advanced sensors like speech recognition and video and AR and VR and head tracking, glasses, eye tracking. But then that raw data from hardware sensors goes into software sensors that adds contextualizing information. We want to know who the learner is, and we want to know what activity they're working on and the context around that activity and what results they're getting from that learning activity. And then those data move along a data pipeline, which can do things like transform the data and filter the data for specific uses in specific kinds of analytics. So that was the first step, get data. And the second is use data. And we have a fancy word for that, learning analytics. And a good way of, we can look at an example of learning analytics used by Duolingo. They're an example where they use learning analytics to optimize the learning experience. And they can actually predict your future. They use some AI and machine learning that applies a learning sciences principle that was discovered over 100 years ago by Hermann Ebbinghaus, and that is about forgetting curves and learning curves. So, newer research has discovered that the best time to practice or relearn a word in, say, a foreign language that you're learning is just before you forget it. So they want to predict just when you're going to forget the word. And they have data from millions, hundreds of millions of users looking at some of the same words. So they have that side of the equation, and then they have your own data, and they can use that data with a machine learning algorithm that has created a model where they can predict when you're going to forget. So Dr. Steve Ritter and I developed a learning analytics process model that is in the book, The Learning Engineering Toolkit. And this model was illustrated by Dr. Schatz. And it starts with the question, what answers do we want to get from the data? But then we need to ask, do we have the data that we need to answer the question? If we don't, we have to develop some instrumentation.
Yeah, and it doesn't always have to be instrumentation. I mean, it could be a traditional test. It could be a multiple choice test. It could be observer trainers who are marking down what they see. It could be these high-end, sensors, neurophysiological sensors, cameras, right? It's the whole range of different ways we can get data into the system to answer these questions.
That's a good point. I guess we should consider the word instrumentation in a very broad sense. It's any way that you're collecting data to help inform the learning engineering process.
Yeah, we just like to talk about the sensors and the high end because, I mean, come on, we're in this community, right? Of course we want to talk about like the high end of things, but it doesn't always have to be. So I just wanted to put it out there.
Exactly. But it's fun, especially in the simulation world. So the third step is to translate the real world question into data questions. So here's an example. A real world question might be, how do I identify learners that need interventions? And I think that's the next click. But the translation could be really two different data questions. First, how do I predict whether a particular learner, the probability that the learner will need an intervention? And then what is the cutoff for the intervention? Because we realize that we're in a constrained world. We probably don't have a budget to give that intervention, or it's probably not practical to give the intervention to every learner. So we can take this kind of information and help inform the learning process. And
Go ahead. Sorry, I was going to say, normally we go in the full tutorial, we go through all the details here, but in this shortened tutorial, we'll just very briefly give a summary that what you can do with learning analytics. A good heuristic is to think about how you can use those data in time. You know, what do I know about somebody right now? How can I use that information right now versus how can I look at historic data to find maybe root causes or diagnose where they are? And how can I use those data to predict and prescribe? So, and Brant is bringing up a nice question or nice comment here in the chat. It's evidence to answer the question, right? Exactly. And what we're trying to do is we're collecting this data in order to make better decisions, in order to be more effective. I often use the analogy of a dragon sitting on its hoard of gold. A lot of times we see people who are just collecting data. Hey, look at all these XAPI statements I collected. Look at all these data pieces I collected, but then they don't do anything with them. Conversely, the other thing I often see is that people get very hung up on how precise the data is. You know, how reliable is this? Can I pinpoint with exact accuracy what somebody's mental state is? You only need as reliable of data as your interventions are going to be, and only depending upon how risky those interventions are. So you don't always have to be precise, but you do need to use what you're collecting data on.
And some insights are better than no insights.
Exactly. And so you can use this kind of stuff for, hints and explanations. And you can imagine, like, in that case, it's not necessarily all that risky. So you can have quite a bit of fuzziness. You can diagnose knowledge gaps if you're looking at historic data, or you could even identify holes within your curriculum where people are just not being very successful. And of course, to predict ahead, you can do learning path recommendations.
So we're going to show you, here is the analytics model that's in the Learning Engineering Toolkit, but you don't have to buy the book to get it. There's a QR code right here. You can use that QR code and go and get this model. And this model gets into some of the analytics methods that are used in the learning analytics process. And if you really want to learn more, we have some other resources to point you to. There are some great tools at CMU's Simon initiative, open source tools. And by the way, Simon is Herb Simon, the Nobel laureate who coined the term learning engineering. And there are some great resources. I highly recommend, if you want to dig into this, check out Dr. Ryan Baker's work on big data in education at University.
Also open source.
Also open source. And his massive online open textbook is available, which is a series of videos and work exercises. So you can learn a lot of these learning analytics techniques for yourself.
Yeah, and I see Doug was asking about the restrictions on the infographic. So there is an infographic on the handouts. It's a different one than this. So the infographic on the handouts is an overall, this is learning engineering infographic. This one here is Creative Commons. So you're welcome to use it. And you can also pick up the learning engineering toolkit that Jim already mentioned to see the full chapter that goes with it. But yeah, just for the infographic itself, feel free to download it and reuse it.
So let's talk about some misconceptions. The first is this misconception that because we're saying learning engineering, that everyone needs to be a learning engineer. Well, there are people that have that title, learning engineer. More often than not, learning engineering is being done in teams of people where no one on the team has that title, learning engineer. But we also can point you to some programs if you want to develop and earn that title. There are numerous programs that are training learning engineers as well.
The other thing that I often hear as a misconception is that learning engineering is, I mean, this goes off of what Jim was just saying, right? Oh, it's a product. It's a thing I'm going to create. I'm going to go build a learning engineering experience. It's this continuous process. And oh, by the way, even though we talk about technology a lot and we love to talk about instrumentation and learning analytics and all of these high-end things, it's not always about digital technology. Sometimes learning engineering just is about, like I said earlier, the Wi-Fi or the user interface, or even, let me give you another example, learning engineering applied in the Gambia. So there's a really interesting learning engineering challenge where young school children weren't making it to the levels of education that the nation wanted. And so there was a really low literacy rate, really low education rate among the youngest kids. And so you could imagine that somebody could have taken an approach where they said, we need more books in the classroom. We need more computers in the classroom, right? We need better teachers in the classroom. But a learning engineering approach was used, and they looked big picture at the challenges. And what they actually found was the major barrier to childhood education was that the schools were too far away from the children's homes. And so they couldn't make it there successfully by themselves because they were young kids and they needed to walk. And so the solution ended up being donkey carts. They were able to locally source the materials, the drivers, the donkeys for these carts, and they prototyped them. Initially, it didn't work very well. They needed to change it up, make the carts lighter, adjust how they added seatbelts to make them safer. And at the end, they were able to successfully build these donkey carts, successfully get kids to classes, and it substantially increased the childhood education. So that is a success story based upon the learning engineering technology of donkey carts.
And did you say that it was an iterative process on developing?
Exactly. Iterative process with data collected. And it's Brand is saying, not just data, but evidence, right? They collected detailed information about, was this successful? Are students making it? What's their feedback to the process? And so they actually had to continue to improve it. It wasn't just a one and done, but they collected data until they got to a place where they met all of the benchmarks. So y'all might be thinking out there, hey, I work in Team Orlando. I don't really need a donkey cart. I mean, maybe you do. I don't know. But you might be thinking, what is in it for me? Why are you guys talking to me about learning engineering? And I would say that there are a few different things depending on who you are. For the folks who are in business out there, if you integrate learning engineering into your proposals or into your business processes, it can give you a competitive advantage. Just think about how, against the backdrop of generative AI, we are really seeing a change between spending time on task. I spent 10 hours writing this proposal versus the quality of things. This has a really depth and quality and evidence that it is going to be successful. I think we are seeing a real shift to needing to have more evidence-based approaches to training and education, not just being able to say, hey, somebody flew 5 sorties in the simulator, or the team spent 20 hours in the simulator, because just that vanity metric of time spent or number of iterations or how many hours is not going to be sufficient to be competitive. If you are in the defense space or the government space, then you want to see that evidence too, right? It's not enough that we're just putting warfighters into a simulator and then sending them out. We really need to have that high-end performance. Human performance overmatch is going to be critical. It's already critical, but it's going to continue to be critical for the future fight. And so elevating our human personnel so that they can do the full range of things we need them to do, that we know that they're going to be successful, that we have that confidence. Learning engineering gives us the tools to do that. And if you're in academia, then, well, you get both, right? You want your students to have that overmatch. I guess we can use that term, right? You want your students to be very effective and successful in what they learn. And you want to have a competitive advantage too against the other universities or other options that are out there. You want to be able to prove that students are successful and that you are achieving your output goals. Oh, and by the way, for everybody, we have a challenge. Jim?
Oh, the challenge of the uncertainty in the world today? Well, we are in a world that is constantly changing, and we have things like generative AI popping up. And we live in a world where I think it's right to predict that how we do things, how we, the workforce and the war force are going to have to learn how to do things differently, because we're not doing them alone anymore. We're doing them in teams with teams of AI agents. And this intelligence augmentation economy changes everything. So
yeah, we're no longer hitting a static target when it comes to training and education. We have to constantly be improving and hitting that moving target as it evolves. So I think what we can do is save the summary till the end, maybe do some questions now, and then we'll summarize right at the very end and give you some more resources at that point. How's that sound?
That sounds wonderful. And as I've been listening, there are a few thoughts that have just kind of come to mind. I mean, I hear a lot of systems engineering in learning engineering. And I think a lot of folks are familiar with systems engineering, and I see a lot of that approach in this. I also am wondering, when you talk about getting data, using data, really understanding this holistic perspective, who the learner is, and all these different aspects. I'm going, it sounds really complicated. It's not like it would take a lot of time and take a lot of energy. But I also know that you don't just do it all from the beginning. Like you said, it's an iterative process. So for an organization or a program office or a project team that's not already set up to do all this, where do you start? What's the first step? Going back to getting the data, getting some data. How do you do that analysis about what data you really need to get and putting the tools in place to do that?
So part of it is broadening that mindset to think about the bigger picture challenge, and that helps set priorities on solving what the real problems are. It's moving beyond designing learning experiences, and often it is the fidelity of the learning experience, but there are other factors involved, and using a human-centered design approach helps address that. And I want to address one other aspect, because we've had questions, kind of the list of pre-questions that address things like, well, there are policy structures and practices that touch things like procurement now. And how can we adjust those kinds of practices so learning engineering can be used instead of the old ways of doing things? And Danielle Zach put in the chat a great answer to that learning engineering in a firm fixed price model in government contracts can be achieved by incorporating several iterations into that contract. So it's really thinking ahead that this is not just a one-off. This is something that is going to be built in.
One of the other questions that came to mind was, the adoption of this. What are you seeing in terms of where it's being adopted, how those barriers to adoption are being addressed? To your point, Jim, a lot of folks in the industry are used to getting all those requirements in an RFP, and if this is not built in there, how do you infuse it in there in ways that could help encourage the adoption? What are your thoughts there?
Say, do you want to take this one?
I was just going to say, for the government folks who are out there, or the people who are writing these proposals, I would encourage you to include learning engineering in those RFPs, or at the very least, include the principles, right? If you're worried that the term learning engineering might be too nebulous, then be specific. Say, hey, look, I want to see multiple iterations of the pilot testing with data and iterative improvements before I will sign off on things. I want to see that you have these different factors, the psychometrician, the learning scientist, the subject matter expert working together. You can articulate some of those pieces. And, Jim already mentioned the Icicle group, the IEEE learning engineering community. I'm sure that they would be very happy to help to articulate some of these KPIs or other process factors if you need some help with that. And then for the folks who are out there on more of the business or academia side of things, I think if you propose these sorts of approaches, and the Learning Engineering Toolkit has a lot of good evidence, a lot of good examples in there on why and how learning engineering is more effective, I think that you can make that a case to differentiate you from some of the other folks who are submitting to a proposal.
And you don't have to swallow the ocean. You can start in small ways. How can you incorporate data-driven decision-making a little bit more than you already are? How can you consider other roles on your team, whether they're full-time roles or augmented as needed, as either by reaching out to experts to get some assistance in very small ways, or as subcontractors on projects?
Yeah, I think a big thing is just having everybody who's supporting a training, education, or exercise activity speaking the same language. So having that vocabulary from learning engineering, having that mental model, that framework from learning engineering, and then having everybody sit in the same room versus more of an assembly line or waterfall like model, but having people actually work together iteratively, that already is a huge step forward. And then the commitment to saying, hey, I'm going to collect some evidence, I'm going to collect some data, even if it is observer trainer collected or subjective, right? Just having some evidence and saying, yeah, and we're going to do at least, 1 or 2 iterations as we go forward. That's already a big step forward. Of course, there are more. That's not all the way to the full vision of learning engineering, but those are steps I think we can all take immediately without too much extra burden.
I love, one of the things I love about this learning engineering approach, and I see this a lot in academia, is the increasing trend toward the team-based experiential learning, where there's a lot of these elements there for our students, because that's how the real world works, right? I mean, we're working in teams, we're around a lot of other people, we're learning together, we're learning from each other. There is a question in the Q&A that's interesting. Is there value assigned to the learner witnessing first and second order consequences as a result of mistakes? So that,
I mean, that's going to be very specific to whatever the situation is, right? So that's not the process per se. That's going to be the different instructional tactics and instructional strategies that are used. And yeah, possibly, but you're going to have to be very specific in your application of learning science.
And the feedback to learners is really one part of it, and the feedback to the learning engineering team is the other part of it. And we can give feedback to the learners during an activity or as an after action review, or all the way to long-term goals. How do they navigate to long-term goals, even career transitions?
Is the measurement of the effectiveness of the learning engineering team? Because if you're taking this approach and you're creating this team, obviously you want to make sure that the team is effective, not just the outcome of the learner. But is the outcome of the learner the measure of the effectiveness of the team, or what other measures are there?
I mean, it depends on what your goal is, right? That's why you really have to start with your goal. So, if the goal is that you want to increase the amount of childhood education, then maybe your goal is how many of these young students are attending school in the Gambia, right? If your goal is that you want to demonstrate that, this whole company received a qualified state, then that becomes your goal. But, it's tough to say because you really need to be goal directed.
Yes, and part of that could be you recognize that you're creating great learning experiences, but the data tells you that there's a motivational issue. So augmenting the team with an expert in behavioral economics or motivational attributes of learning is something that you might want to do. And you can use the same research-based learning engineering approach. So you could do some A/B testing. It's like, has it helped to have this behavioral economics expert on the team during this project? And how can we adjust the engagement of the team working together to optimize?
Yeah, and I hope that you guys are getting this point that learning engineering is a lot closer to like DevOps or continuous integration to continuous deployment of software than it is to like the old standard, like make a product, do a waterfall model. Because even after the prototyping phase, you're continuously still collecting data and still improving the learning experience. It's almost like learning as a service over time. And I'm saying learning versus education or training or exercises, because again, all of those are just different tools in your toolkit in order to achieve the human performance that we want. In fact, and this is one of the questions that we received in advance, where do you see this going with defense in the future? I think defense and high-end industry as well, and maybe other fields, are seeing this merger of learning and development, preparation, training, education, exercises, and performance. And we're seeing these become a lot more overlapping. especially as we're getting more artificial intelligence augmentation. And so people are being augmented so that maybe when they're outperforming an operation of some kind, they don't need to be the expert at it. They need to be pretty good and then augmented with artificial intelligence and maybe get some just-in-time learning. And maybe they got some preparation in advance. And all of this is carefully balanced through a data-driven approach. So we know what that individual already knows, what experiences he or she's already had, and then can optimize the AI support in real time for that. So that's kind of where I can imagine things going, and doubling down on why we really need learning engineering as part of that larger process.
What are your suggestions about where someone would go to connect with some of the subject matter experts they might want to integrate into their team as they're trying to integrate learning engineering into an effort that they're doing internally or for a proposal or something?
Sure. The first place is the IEEE
Icicle community.
And in less than 2 weeks, the Icicle 2023 conference is happening in Pittsburgh. So if you can cancel your plans for the 24th through the 26th and somehow get to Pittsburgh, that is what you should do. That's what I would do if I wasn't already registered and had booked travel to be there.
And we've already mentioned the Learning Engineering Toolkit, so that's good stuff. Some of the principles are in the Modernizing Learning book, which I mentioned only because it is a classic and also it's free, so that's helpful. We on the handouts, I already mentioned, we have an infographic that gives you a nice overview. And then Jim and I will hopefully be presenting this tutorial in its long form at ITSEC again this year, assuming that they accept us.
Yeah, well, as I told you, I was going to ask you about that. But also, for those of you that are our guests today, I always like to ask our team that does speaking, what do you need? What would be a benefit to you from those of you that are in the audience? How are there opportunities for you to partner with, say, and Jim, for example? And what would that be?
So that's the question for the audience, right? So yeah, so put into the chat or feel free to reach out to Jim and I, or, as we've already said several times, the Icicle group. The Icicle group is free to join and has a Discord channel. So it's really easy to get in touch with folks. And if you haven't noticed, there are a lot of free or Creative Commons open source resources, because one of the defining characteristics of this community is that people really are appreciative of each other and they like to share. And so it's a great community to be a part of. By the way, too, I'm seeing a lot of really good comments and questions here in the chat. So I did want to address one comment here about learning engineering versus ADDIE or versus the traditional approaches. I just want to be clear that there are some excellent folks out there that are doing learning science, learning engineering kinds of principles in practice. And they can use a model like ADDIE or other traditional instructional systems design methods to accomplish some of these goals. The big difference is with learning engineering, those nice to haves, such as iterative design, a data-driven approach, integrated team, they become have to haves under a learning engineering paradigm. And it gives us the vocabulary and the framework to make sure that we're doing those elements successfully. So just like with Alexander Fleming in the lab with penicillin, sure, you can have a couple individuals who are geniuses or who are lucky or whatever that are very successful at a local level. But learning engineering helps us scale it up. So it's not just a local level, but it becomes reliable at scale and into the future. And so that's really where a lot of the difference comes in. And so I know we're trying to make a big case to make a stark difference between the traditional way and the learning engineering way. It's not always stark at a local level, but I think when we start to think at, let's say, an enterprise scale, at a Department of Defense scale, then it does start to become a pretty substantial difference.
Are there places within Department of Defense that you're seeing adoption of an integration of learning engineering more than others, and where would that be?
Yes, one good example is the simulated synthetic training environment, and the Steel R project is using learning engineering as that iterative data-informed process, and doing some really innovative stuff.
Also, shout out to the Air Force. I know that there's a lot of folks there who have been really promoting not only learning engineering, but learning sciences and upskilling of Air Force learning professionals. And they have a great community.
And that's another reason to get to the Icicle conference in 2 weeks, because there'll be a team from the Air Force there presenting what they're doing.
Yeah, exactly. And also the Army's Learning Journal has some good stuff. Not only that, we've put a learning engineering article into that, but also that community has been doing a lot of work as well. Oh yeah, and Doug mentioned, by the way, that in addition to the Icicle conference, the Advanced Distributed Learning Program will be hosting a Total Learning Architecture Plug Fest at the same time in conjunction with it, which is a good point. So thank you for calling that out, because although learning engineering does not require the use of technology, does not require you to have this like learning ecosystem approach, it certainly goes hand in hand with that. And in fact, if we want to have a learning ecosystem approach with complex systems talking to each other, then you absolutely need to have a learning engineering approach to go with it, so that we are effectively capitalizing on that technical backbone.
And I'll put on my IEEE LTSC hat and mention that the IEEE Learning Technology Standards Committee is co-sponsoring the ADL Plug Fest. And the focus is around using data standards and technology standards so that distributed learning can be interoperable. And it really enables this engineering mindset, where it's a system of systems and parts can be modularized. And that's really the way that we make scalable systems.
I think that's a really good transition for me to bring back up the slides, and we can do the kind of final piece here. So let's do that. So in summary, learning engineering is a process. It is more of a verb than a noun. It is about having this continuous integration, continuous deployment, data-driven approaches that are focused on the outcome. And that outcome could be that we need more kids in school, or that we need to improve the Wi-Fi in order to get to our goal. We use the learning sciences. So just like the Duolingo example, where they draw upon the Ebbinghaus curve and then use data on top of that, and then determine the intervention based upon those learning sciences principles. It's human-centered. We need to know our learners, our other stakeholders, their context of use, and we need to use data to optimize what we're doing so that we can scale the quality of learning, not just to an expert teacher in one classroom, but broadly, so that we can think about issues beyond just the curriculum, because sometimes the solution is a donkey. And so we can leverage the latest tools, just like learning ecosystems, the total learning architecture, advanced technologies, AI instrumentation, and so on. And here are some resources you can check out. You can just search for these. This one is available online, 7 Things You Should Know About Learning Engineering. The Learning Engineering book for online education. And of course, the one we already mentioned, because Jim and I worked on this one, and we like this one quite a bit. It's good stuff. And there is a link. You already got it, but it's just Icicle. It's IEEE-icicle.org, so that's pretty easy. But if you want the QR code, there you go. And the infographic, you can also get this under the handouts. So you can do the QR code if you want it on your phone, but under handouts, you can also get the infographic that we created for this.
I love that you provided so many wonderful resources, such a great explanation of learning engineering. Can't wait to sit in your tutorial at ITSEC coming up in 2023 and learn more. And since the Army synthetic training environment is across the hall from Tech Grove, I'm going to go over there and ask them about their project that uses learning engineering, learn a little bit more there. But thank you all who joined us today for taking your time to dial in and listen and learn. This webinar has been recorded. It will be available on the NTSA events website within 24 to 48 hours. All the wonderful slides that you saw here that Say and Jim provided, the narrative around it, the Q&A, you'll be able to go back and revisit that and go back and pick up those references to all the great resources they provided. Hope that many of you will join us again in August for our next NTSA Tech Grove Connect webinar. So watch your emails from NTSA for information about the team that we'll be featuring there. And don't forget to go out and check out centralfloridatechgrove.org so you can stay connected with Team Orlando and Tech Grove and be aware of all the great opportunities to learn and engage and innovate with us. Thank you all. Have a wonderful rest of the week. Thank you, Say. Thank you, Jim.